Hey everyone, this video is on solving linear systems by graphing. And the first thing that we're asked to do is to find out how many solution a line has. So just a quick refresher that a line consists of several different points on that line, and that line goes on forever. So there are infinite points on this line. So any x or y value that would satisfy the equation would be a solution. But also remember the density property. If I were to zoom in right here, there would be even more points. So the density property also indicates that we have infinite solutions on our line. So for example, if the equation of my line is y equals x plus 5, well, I could do 1 plus 5. So that would 1, 6 would be a coordinate. I could do 2 plus 5, so 2, 7 would be a coordinate. I could do 3, 8. I could do 4 and 9. I could do 1.1 comma 6.1. Like there's no end to this. There's infinite solutions. But the next question says, how many solutions in common do two lines have? And if we are talking about two lines, this line has infinite solutions. This other line has infinite solutions, but there's only one solution that's in common. So usually you're going to have one common solution, usually. So a linear system of equations is a set of linear equations involving the same variables. Okay, and just a heads up, they usually have one simultaneous solution. But just so that you know, a quick note is the number of variables has to match the number of equations. So for example, if I have one equation with two variables, I can't solve it. If I have two variables, I have to have two equations. If I have five variables, I have to have five equations. So three possible scenarios for solutions. The first scenario we've already seen, it's right here. And that is if I have two lines, I could have one solution, right? So we could either have one solution, but sometimes our lines are going to be parallel to each other. And if the lines are parallel to each other, then we have no solution. And sometimes the sets of equations that we're looking at are the exact same equation, but sometimes we don't realize it just by looking at it. And if I graph out two equations on top of each other, where are they going to intersect? Everywhere. So there's sometimes a possibility of having infinite solutions. Okay, so let's look at an example. It says here the cost to attend Good Life Fitness for 1 week is $10. So that right there is one piece of information. And then it says the cost to attend Anytime Fitness for 1 week is $2 plus an additional charge of $4 per visit. So it says write two equations to represent each fitness club, but then it says don't forget to write your let statements. So really what's happening here is we don't know how many times a person is visiting, and we also don't know how much you are paying altogether for the full week. And so that means right here that we have the number of times visiting is going to be our first let statement, and then our second let statement is going to be the total cost. And because the total cost depends on the number of times visiting, that tells us that the total cost is the dependent variable, which would be y, and the number of times visiting would be the independent variable, so it would be x. So let's go ahead and write out our equations right here. So let's write one for good life. And then let's also write one for anytime. So for good life, we know that it's $10 for the week. And just so that you know, we are writing an equation just for 1 week. So good life, if you go for 1 week, you have to pay $10. If you go once, you pay $10. If you go every day, you pay $10. If you decide to do 2-a-days, you're gonna still pay $10. Like, you still have to pay just a flat fee of $10. So you're not paying anything per visit. So that means that your slope would be 0, right? So it's technically 0x plus 10. All right, now for any time visit, our total cost, we have to pay $2, right? It says we have to pay $2 plus an additional $4 per visit. Okay, so let's go ahead and write out our graph out what's happening here. So on our x-axis, we're always going to put our independent variable. So here we're going to say number of visits. And then on our y-axis right here, we're going to put our total cost. And this is again just for 1 week. So, and we'll put 0 here. So I'm going to space this out, and I'm going to put 1 visit every like 2 tick marks. So 1, 2, 3, 4, 5, 6, 7. And then here for total cost, I'll go by $1. So this would be 1, this would be $2, 3, $4, 5, $6, so on and so forth. Okay, so for good life, we know that for good life, you're paying $10 flat fee all the time. Your slope is 0, so you have a horizontal line. So your line is going to look like this. Okay, so this right here is good life's line. And then for any time, we know that any time starts at $2. No matter what, you have to pay $2. And every time you visit, you pay an extra $4. So after 1 visit, you're paying an extra $4. So it might be helpful to kind of get a table of values here. So for 0 visits, we're going to pay $2. 1 visit, we're going to pay an extra $4. So that would be $6. 2 visits would be 10. $3, 3 visits would be 14, so on and so forth. So we can graph that out. So 0, 2, 1 visit is $6, 2 visits is $10, 3 visits is $14, or we could do rise over run. Just be very careful, because the rise would be 4 and the run would be 1, but check your scale carefully. Okay, look at it very carefully as you're doing your drawing. Okay, cool. So then I would connect those dots. And this tells me information for anytime fitness. Okay, so now question B said to graph both lines. Okay, so then part C says to determine the conditions under which you should select each gym. And it says that there are 3 conditions. So let's talk about what these 3 conditions are. If you notice right here, they end up being the same price at 2 visits, and the same price is $10. So I want you to fill in these blanks that I'm going to get set up for you right here, and then I want you to bring it to class, and then we'll take it up next time we see you in class. So the first blank that you would fill in is, if you go less than 2 times, you should select which one. Then I want you to fill in right here, if you go more than 2 times, you should select And then lastly, I want you to fill in, if you go 2 times, you should select and then fill that in as well. Okay? All right, example 2 says to solve the following linear system. And then in brackets, it says to find the POI. So just so that you know, the POI stands for the point of intersection. And in order for me to be able to graph out any lines, I have to isolate y in both equations. So I'm going to call this first one equation number 1. So in equation number 1, in order to isolate y, I would have to add x to both sides. So I would get 3y equals x minus 3. Then I divide everything by 3, and I end up getting y equals 1/3 x minus 1. So how do I graph out this line? Well, I know my y-intercept is -1. I know my slope is 1/3, so that means I go up 1 to the right 3. Again, I'd go up 1 and to the right 3. And I can also just extend my line by going backwards. Now I would connect those dots. And this is my first line. So just a reminder, you can write down the isolated y version or the original version. It doesn't matter. Okay, now equation number 2, I want to isolate y here. So to isolate y here, I would subtract the 2x and the 10. So I end up getting 2y equals -2x minus 10. Divide everything through by 2. So I get y equals -1x minus 5. Well, what does that mean I have to do right here? I'd started at -5, and then the slope right here is -1. And -1 is a fraction, is -1/1, right? So that means right here that I would go down 1 to the right 1. And if I run out of room, I can go the other way as well, okay? And sometimes you might not see that they're going to intersect because you just don't realize that you can go the other way. So it's really important that you go, that you understand that it could go the other way as well. Draw the arrows on your line. Label the equation of your line. And the whole point of this is to see what's the one single point that satisfies both equations, and that point right here is -3, -2. So your POI, your point of intersection, is going to be -3, -2. Okay, so this is your point of intersection. It's really important that you realize that that's your answer. So now let's do a formal check. So to check that your solution is correct, we're going to do an LS-RS check. LS means left side, RS means right side. Now, before we do that, you need to write down right here that you must do the check in the original equation. Because if you don't do it in the original equation, then you won't know for sure if you made a mistake when you are isolating the y. So you could have made a mistake isolating the y, graphed it out, gotten an answer, and then you check it in the equation after you've isolated the y. You won't even realize that you made a mistake isolating the y. Do you see what I'm saying? So it's really important that you check in the original equation. So let's do our original equation right here. So we're going to do equation number 1, says 3y minus x equals -3. I'm just going to cut this down the middle so we have some space for this. So first thing we're going to do is left side. And our left side is 3y minus x equals -3. What am I going to check? I'm going to check my point of intersection. So I'm going to check -3, -2. So I'm going to sub in -3 for x and -2 for y. So here I'm going to do 3 times y, and y is -2. And then I'm going to say minus x, and x is -3. And my bad, I'm very sorry. I said let's just do the left side, and the left side should just be 3y minus x, right? This is the left side of my equation right here, okay? So 3 times -2 is -6. Minus -3 means +3 right here. Put your equal signs in front. So -6 plus 3 is -3. We also know that the right side is equal to, and if you look at your equation right here, the right side says -3. This is my right side of my equation. So right side equals -3. So now we can say left side equals right side, check. But we are only 50% sure that we got this right because we have to check in both equations. It could work in one equation. Remember, there's infinite points on this line, but we need to make sure that it's a point that works in both equations. So we're also going to check our second equation as well. So 2y plus 2x plus 10 equals 0. We'll do our left side first. So our left side is 2y plus 2x plus 10. And I still want to check the same exact point of intersection. So here I'm going to say 2 times y plus 2 times x plus 10. And we know that the y is -2. And we know that the x is -3. And now I just have to do some evaluation here. So 2 times -2 is -4, 2 times -3 is -6, and then plus 10. -4 minus 6 is -10. -10 plus 10 is 0. And then we also know that our right side is equal to 0. So our left side equals our right side, and we can check. Okay, in our last question, it says two health clubs, Superfit and Body Plus, offer monthly memberships. The total monthly cost for each club is represented by the graphs below. Which of the following is truer? Is true. Excuse me. So question or choice A says Body Plus is always cheaper. And right now it does appear as though Body Plus is cheaper, but it's not always going to be cheaper because we have to extend this line right here and use this line to help us out to make sure that we are doing this correctly. So also just be aware that because this is 15 and this is 30, this is going up by $15 every 5 classes, right? Because this is 5 classes right here. So, or $3 per class. So we're going to go up another $15 for another 5 classes right here. So if I were to connect this point right here using this pattern, I can connect that right here. And then I'm just going to extend this super fit line right here. That's why A doesn't work. And super fit is always more expensive also is not true because eventually we get to a point where Body Plus becomes more expensive than super fit. These are also like pretty much saying the same exact thing. So there's no way that one of those is true and the other one isn't. They both have to be false. Choice C says Superfit is cheaper if the number of visits is fewer than 7, but that's not true because Superfit is more expensive at the beginning and then it becomes less expensive. And then choice D says Body Plus is more expensive if the number of visits is greater than 9. So let's look and see what it says right here at 9. Anything after 9, because at 8, Body Plus is still a tiny bit cheaper. It's hard to see, but it is actually a tiny bit cheaper. But if the number of visits is greater than, I guess we should say, or equal to 9, Body Plus is more expensive. Okay. All right. That's it for this video. I hope you have a great day. Let us know if you have any questions. See ya.